Good morning everybody. Today we will be dealing with experiment number 3, which is polarity test and connection of 3 single phase transformers in star delta, delta delta and open delta, and to find efficiency and regulation under balanced resistive load. So coming to the aim of the experiment, first part of the experiment will be to check for the polarity, which is popularly known as polarity test conducted for any transformer. Polarity test will be mandatory in order to connect any two transformers in parallel. So the second part of the experiment is to connect 3 single phase transformers in bank configuration to get star delta, delta delta and open delta configuration, and then perform direct load test on them. So let us go to the apparatus required. We need an ammeter of range 0 to 10 amperes, 2 in number, voltmeter 0 to 500 volts, 2 in number, another voltmeter 0 to 600 volts range, 1 in number, wattmeter of unity power factor type 0 to 10 amperes, 0 to 600 volts, 2 in number, another wattmeter of different range which is unity power factor 0 to 10 amperes, 0 to 300 volts, 2 in number, single phase transformers of rating 2 kVA, 400/230 volts, 3 in number, and we need a resistive load bank which is 3-phase bank of 10 amperes. Now coming to the circuit diagram, first we shall be dealing with the first part of the experiment, which is polarity test, in order to check for the polarity as per the dot convention. So this is the circuit configuration. Initially here you are having an auto transformer. From the auto transformer it is connected to primary winding of the transformer P1, and the other end of P2 is connected back to the supply. Then we have a voltmeter here in order to measure the primary voltage, and the notation for this is V1. Its range is 0 to 300 volts, and along the secondary we have another voltmeter connected across the secondary, and that voltmeter range is 0 to 300 volts. Now here we have a voltmeter connected between P1 and S1, primary of the transformer and secondary of the transformer. Between them we have a voltmeter, and its range is 0 to 500 volts. Whenever we come to polarity test, we have additive polarity and subtractive polarity. So what exactly we do here is, once the circuit is connected, we try to check the reading V1, we try to check V2, and then we try to check the third voltmeter, we can call it as V3. If V3 reads sum of the readings of V1 and V2, then it is said to be additive polarity. And in case it reads V1 minus V2, it is said to be subtractive polarity. In either of the cases, same circuit configuration will be followed. Only thing is, if we get additive polarity, in order to get subtractive polarity, we will have to interchange the terminals S1 and S2 of the transformer. Now let us move on with the circuit connections. So the same circuit diagram is shown over here. Let us see the apparatus required in this particular configuration. We have an auto transformer that we have seen in the apparatus, and we are having 2 voltmeters, and also we have inbuilt panel voltmeter. Now let us see the circuit connections. So if you see the circuit connections, from the utility it goes to auto transformer. So let us see the same here. From the auto transformer it is connected to P1. So you can see the connectivity here. From transformer it is going to P1. P2 is getting connected back to the neutral. That is, it is getting connected back to the other end of the auto transformer. P2 is getting connected to other end of the auto transformer. We have a voltmeter that is connected across P1, P2. We have a panel voltmeter here that is connected across P1 and P2. Then across the secondary S1 and S2 we are having another voltmeter. Let us see the connection here. So across the secondary we have another voltmeter connected, as we have seen in the circuit diagram. Voltmeter V3 connected between P1 and S1. voltmeter V3 connected between P1 and S1. So this shows the connectivity. So to just summarize the connectivity, first it starts from auto transformer. From the auto transformer, it is connected to P1. Then P2 is coming back to the auto transformer. We have voltmeter that is connected across the P1 and P2. Then across the secondary, we have another voltmeter V2. Then we have another voltmeter V3 between P1 and S1. So this is the circuit connection configuration. Next we'll go for the working. After checking the configuration of the circuit, now let us switch on the supply. Once we switch on the supply, we start varying the auto transformer gradually, and we vary the auto transformer until we reach the rated voltage, that is 230 volts. Gradually it is varied. So now we observe the readings of all the three voltmeters. So V1 is reading 230, V2 is also reading 230, while V3 is reading 0. Since V3 is reading 0, we come to the conclusion that it is subtractive polarity. So the reading V1, V2 and V3 should be noted down in the following tabular column. Now since we have observed subtractive polarity, if we need to go for additive polarity, we just have to interchange the terminals S1 and S2 to observe the polarity. As explained just now, the terminals S1 and S2 have to be interchanged in order to observe the additive polarity. So S1 and S2, after interchanging them, follow the same procedure. Slowly vary the auto transformer from initial 0 position up to the rated voltage, which is 230 volts. So now we can clearly observe that V1 reads 230 volts and voltmeter across secondary also reads 230 volts, as this is a 1:1 transformer. Now clearly you can observe the reading on V3, voltmeter V3, which is almost equal to 460, which is sum of V1 and V2. So this represents additive polarity. So before doing the parallel operation of transformers, first we'll have to check the polarity, and here also before doing the load test we'll have to check the polarity. This is the procedure by using which you will check whether it is additive polarity or subtractive polarity. Usually for performing any experiment, the configuration must be in subtractive polarity. This is the procedure by which you can check additive or subtractive. In case it turns out to be additive, interchange the secondary terminals to obtain the subtractive polarity. Next we will go to the circuit diagram for the load test. So this completes first part of the experiment, that is polarity test. In the next video, we will go to the second part of the experiment, that is conducting load test.